Good afternoon, Professor Marc Fontecave, Mrs. Christy True, Consul General of France in Hong Kong and Macau, President Professor Freddie Boy, honorary guests, colleagues, friends, and fellow students. I'm Sok-Han Chang, the Associate Vice President of City University of Hong Kong and the facilitator of today's lecture. First, I would like to welcome you all to the France-Hong Kong Distinguished Lecture. The series was founded by Professor Philippe Sialet in 2005. Since then, the series has showcased the work of over 20 distinguished French academicians until 2019. And then we know what happened for that 3 years. Now, it's our great pleasure to resume the series. Today, it is our honor to have Professor Marc Fontecave, member of the French Academy of Sciences, member of the Academia Europaea, member of the Royal Swedish Academy of Sciences, and professor at the Collège de France to give us a talk on necessities and challenges of the energetic transition. Before I invite Professor Fontecave to the stage, may I invite our president, Professor Freddie Boy, to deliver the opening speech. Professor Boy, please.
Yeah, good afternoon, everybody. It's not going to be a speech, it's just going to be, say, a welcome. So Professor Marc Fontecave, Consul General with Drille from France, and Consul General of Hong Kong and Macau, and distinguished guests, ladies and gentlemen, good afternoon. To begin with, I think, of course, CityU is very proud that we have Institute of Advanced Study, and more recently, the show Oppenheimer has helped to promote this institute in concept because it came way back in 1930 in Princeton, started with Einstein and Oppenheimer, no less. But in reality, the whole concept, I understand, began a few hundred years ago in France. So the original, may I say so, came from France, Collège de France. And we are very happy that we are connected today through Philip's wonderful work to such an esteemed college and concept. We have a lot to learn from France. I must admit that in my past life in Singapore, I did a lot of work with my French colleagues, and they are very nice and warm to work with and very effective. Real collaboration, I call it, yeah? From Montpellier, from Marc Abadie, to sending people to Strasbourg, Marie Le Pen, no less Nobel Prize in Chemistry, and so on. Of course, the Sorbonne, and so on. So I'm sold and bought, whatever it is, to working very effectively with France, and I have every intention to do that as a young and promising president. But today, we are really delighted to have Professor Marc Fontecave to come and address a very relevant issue, necessities and challenges of the energetic transition. Whilst the Institute of Advanced Study really is free-ranging to pretty much study anything theoretical, we know today that there is, shall I use the word applied research, and then there is yet to be applied research. All basic research today invariably have become yet to be applied. And we are no less as a university focusing on this approach. And I think this topic is really very relevant, necessities and challenges of the energetic transition. And the goal is, in his words, in Professor Marc's word, is to teach science in the making. So our professors have a lot to learn about this. And in this lecture in particular, he will discuss the current energy situation, possible scenarios for the 2050 trajectories, and the scientific and technological challenges that we are facing, and not will be, but we are facing, taking the case of France. CityU is committed to promote scientific research and transform the society, and this lecture offers a very great insight and opportunity to discuss pressing issues, global issues, but also very relevant to Hong Kong. We don't need to be reminded that the climate change has hit us in a very real way. A few weeks ago, we had what we call the black rain the biggest rainfall in the whole history of Hong Kong. And because of that, the IAS theatre has been damaged, protected as it was, still damaged, and we do apologize. We couldn't get the lecture into that wonderful theatre. But it goes to show how relevant the topic is today. So I'm not going to say very much other than very exciting to have him here. I sincerely apologize that I have another duty to do after this, and while I won't be attending the lecture, I believe it's recorded, and I look forward to looking at it. Thank you.
Thank you, Professor Boy. Now, I would like to invite Mrs. Christy Drew, Consul General of France in Hong Kong and Macau, to come to the stage to give the opening speech. Mrs. Drew, please.
Dear President Boy, dear distinguished professors, dear participants, thank you very much for your invitation in the framework of the France City Distinguished Lecture Series. These lectures are a great example of successful cooperation between France and Hong Kong. And our special thanks go to Professor Saleh for his important and faithful involvement. I'm pleased that you chose energy transition as a topic, as it is more than ever urgent to address climate change and promote sustainable development in France, Hong Kong, and the rest of the world. France and Hong Kong are natural partners on these issues, as our governments share the same goal of achieving carbon neutrality by 2050. I'm particularly happy to see Professor Fontecave back in Hong Kong a few months after your participation to the seminar organized by the Hong Kong Institute for Clean Energy last March. Professor Fontecave is indeed one of France's most eminent scientists. He has worked on energy issues for many years from a research perspective, but also advising the French government and participating to the public debate as to the best way to reach our goals. Energy transition is at the core of our journey to achieve carbon neutrality. For that, we need to emit less and absorb more while avoiding soaring energy costs that will hurt our economies and could provoke social instability. We know that there is not one fitting pattern for every country, which may have different energy policy mix. France, for example, has made the choice of relying more on nuclear and renewable energies, which, by the way, allows us to have among the cheapest energy production costs in Europe and to limit our dependence on energy imports. What is for sure is that all the countries in the world need to replace fossil fuels with low carbon or neutral energy sources, optimizing energy consumption, efficiency and storage, developing smart cities while retrofitting existing buildings, finding carbon capture solutions, making the best of our waste and more. Innovation will be key, and French companies have demonstrated that they already have green, innovative solutions which could already make a huge difference today. Together, by joining our knowledge and our creativity, we can continue to develop new, effective and transformative solutions to propel us towards greater sustainability, resilience and clean energy. Just a few more words to share the French experience. The French government has long intended to reduce its dependence on oil, gas, and coal imports, in line with the commitment to make France one of the first major countries to move away from fossil fuels. Our president has recently announced an increase from 33 billion to 40 billion euros to make this happen. The French government has also adopted a detailed planning of the actions to be taken to meet our targets, broken down for each sector and in the territories so as to reduce its greenhouse gas emissions by 55% by 2030. This plan is based on science and objective results. Let me just emphasize this one point. For France, the contribution of science is key, and the dialogue between scientists and the political sphere is essential at the national level. More international exchanges can also benefit us all. Professor Fontecave, you are both a scientist and, I believe, an optimistic, and we are very eager to listen to your thoughts as well as the discussion that will follow. I wish you all a great conference. Thank you very much.
Now let's invite Mr. President and Madame Druhl, Professor Fontecave, Professor Xiaolei, Professor Wang Xunyi to take a picture. Thank you very much.
Now may I invite Professor Fontecave to deliver the France-Hong Kong Distinguished Lecture. Professor Fontecave.
It should work. Can you hear me? Yeah. Thank you. So, dear Professor Boy, he told me he had to leave. Professor Cheng, thank you for your presentation. Mrs. Druhl, thank you also. And cher Philippe, it's a great honor to be here to talk about this important topic. And yes, indeed, what I plan to do for the next 50 minutes is to give you my broad views about what is the energetic transition. In fact, I feel legitimate to do so because I've been working on many aspects of this energetic transition in my lab for almost 30 years, in particular on the question of storing electricity. As you know, if we don't use the excess of electricity, we lose it. So there is a real issue of storing energy. There are many ways to do so, but I'm not talking in detail of that. The second reason is I've been the president. I'm still the president of the Energy Committee of the Academy of Sciences in France for the last 5 years, and we work to advise the government and industrial companies and making reports on different topics. Recently on nuclear energy. Soon I'm finishing a report on the biomass, how can we use it, and so on. And last, I recently published a book where I explain a few things. In particular, I dared to say things that people usually do not like to hear. I hope you will like it, but I will continue with these ideas. This book has a first title called Stop to the Catastrophism, and some truths about the energetic transition. And what I wanted to do, besides explaining what is the transition, is to answer to some people. I wanted to answer to those that complain all the time that we are going too slow, we are not doing enough, and so on, that in fact, everybody now is engaged in this transition. The states, the governments, the people, the enterprises. So, of course, it's never enough, it's never fast enough, but really people are concerned. I wanted also to answer to those people saying that now it's clear that science is only a source of problems, that instead science, innovation, knowledge is part of the solution. We should try this first before giving up. And we have many things to solve still. And this, if we are clear, we should really understand that we need to solve some questions. Technical, scientific, but also economical and social and geopolitical. And that's why we need time. We really need time. So I wanted also to say to those people that say that the problem is so urgent that we have to solve everything in the next 2 or 3 years. This will never happen. So if the end of the world is within the next 2 or 3 years, we can forget it and that's the end. Because we will need more time. And we have to accept that and work. We have to work. Not only demonstrate, but work. And another point that I mentioned here is that we are giving to people too many unrealistic objectives. And I say this is a political mistake because by doing so, we take the risk that we will not reach these objectives because they are not reachable. And at the end, the people will complain that we are either liars or incompetent. In both cases, it's not very good. And I will say a few words about adaptation. In fact, we have to work for the transition, so moving from one energetic system to another, but we have also to consider that temperature will increase more than 1.5 degrees, for sure. That's my opinion. And we have to adapt all our countries to that situation, rather than saying every day 1.5 degree, 1.5 degree. Yeah. So the question is, the two objectives I will challenge are simple. One is zero carbon in 2050, and the other is 1.5 degree. What I dare to say is that we will not reach these objectives. We need to do our best, but it's a global problem, and tomorrow fossil energies will continue to be used for all these reasons. I don't go into the details, but it is difficult to get rid of these fossils. Many countries will continue to use them. The world population will increase. We will have massive needs for carbon. Not everything will be electric. Actually, I myself do my best to avoid using the word decarbonation, but it gives the impression that the world might be carbon-free. I mean, you are all essentially made of carbon. Everything here is carbon, and tomorrow we will need carbon, we will need polymers, we will need things like that. So I try to use the word defossilization rather than decarbonation. The massive construction of new nuclear plants, wind and solar farms will require massive quantities of energy and emitting materials, cement, steel, and so on. And not all CO2 will be captured and sequestered. So you see, every day you can see that the world is continuing to consume oil. This summer, I took this information from the International Energy Agency. You see, it was recently, August 2023. So the world in 2023 has never consumed so much oil. That's the reality, and I can show you. I can show you hundreds of such claims in the press. And you can I just take this example as a way to really show how it is difficult to think in terms of what is carbon-free or what is not carbon-free. I mean, if we take mobility, as you can see here, today it's about 1 billion cars on the Earth. They are all thermal. And we are working hard to make them electric. And any prospective study, like here it's Bloomberg, but you have many like that, which are consistent, is that in 2040 or 50, you will have 500 million that will be electric. It's an amazing revolution. But in 2040 and 50, you will have 1.5 billion cars. So you will have exactly the same amount of thermal car in 30 years. And furthermore, as you can see on the right, does it work? Yeah, here. An electric car is not zero carbon. So even if we would have 1.5 billion cars on the Earth, we will not have zero carbon. And for example, you have to explain to people, because they sometimes do not understand, that the problem is that it's not that a car is electric or thermal. It depends on what electricity you put on the car. So, for example, replacing diesel car by electric car in Poland, in India, has absolutely no effect on the emission of CO2. Even in Germany, you lose only 1/3 of the emissions. So the German can do all their cars electric. It will not change anything about the zero carbon unless they move to completely zero carbon electricity. And France is a particular country because its electricity is 90% defossilized, and this is why you have this effect. But again, even in this case, even in a country that will never do better in terms of defossilizing the electricity, the electric car is not zero carbon. So at the end, it means that, in fact, while we would like very much to have 1.5 degree more in 2100, as the Paris Agreement has indicated, in fact, this will never happen. And you have here a figure coming from a recent Nature paper showing that the extreme scenario from IPCC will not occur because we are trying to avoid that. The 1.5 will not occur. So we are dealing with a planet that maybe will have to face 2.5, 3 degrees. And if we don't accept this idea, we will not do the correct things to address this question. And that's why it is also important, besides working for the energetic transition, also to have policy for adaptation to such a high temperature. This means a lot of things. It means, that long list, but I go rapidly: home renovation, protection of infrastructures, factories, public services, protection of energetic system, land use planning, new urban planning, adaptation of the hospital service, weather forecasting systems. So we have to take care of that as well. And not just thinking, okay, we will reach the 1.5, so we don't need to take care of that. Of course, it's a problem because this will cost a lot, as the energetic transition cost. So, as we need money, we need growth. And I also answer to those who think that it's degrowth the solution, that this is not the case. And in fact, as you can see here, you have several studies showing that through some index that have been developed here, for example, there is this environmental performance index which have been developed by the University of Columbia and Princeton, which combine different parameters. You have the list here. It's a general view of how the environment is treated. And as you can see here from this curve, I mean, the quality of the environment is dependent on the GDP per capita, which is obvious, but this is shown here. And also the Human Development Index that you see here is also a function of the quantity of energy per capita that is used. And I like to show you this cartoon where you have two, prehistoric men discussing, and they say something is just not right. Our air is clean, our water is pure, we all get plenty of exercise, everything we eat is organic and free range, and yet nobody lives past 30. Yeah, so that's why we have to get money to solve the problem of the energy and to solve the problem of the environment. So of course when you say, okay, we need growth, economical growth, but there is a challenge here that you have, I mean, it's correct if we succeed in decoupling growth and CO2 emissions. So far, they have been together. So there is a kind of contradiction. So we have to show that it is possible, or to show that it is not. But in that case, we have to take the conclusion. So far, of course, the CO2 emission increased, but in some places, as you can see here, and in particular in the US, since the 20 last years, and in Europe, actually, European Union, since the 80s, you have CO2 emission decreasing. And at the same time, the GDP increasing. Actually, the United States have a huge slope here as compared to the others, actually comparable to China for the last years. The reason why it works like that for the US is quite simple. It's just because they have replaced the coal by the gas, which is less emitting because of the shale gas that they have developed. For Europe, unfortunately, it's different. And as you can see here for France, where you have this decrease since 2000 in CO2 emission and also CO2 emission per capita, what you see here, it's a very bad point, is that we have a slow industrial erosion. So we are producing less and less, and we are kind of exporting our emissions, but it's not good, of course, so it's not a good reason. Let's go now to the scenarios of the energetic transition. Actually, I will very often support my demonstration on the case of France, but actually the principle that I will develop should apply for any country. In fact, even though we think that we should use less energy, in fact, as you can see here, any scenario for the world is about an increase of the energy consumption and an increase in the electricity consumption with a slope that can be much larger for electricity. Because, of course, we will talk about electrifying a lot of activities. In France, then, but we have this situation here, and we have this scenario. What you see in the left is exactly, I mean, will apply to any country. An energetic transition today for any country is reducing energy consumption. The question is how much? The second thing is increasing the electricity share, of course, with carbon-free electricity. Again, to which extent? And the third point is replacing fossil carbon by non-fossil carbon. Again, I will insist on that point that fossil fuels are not only fuels, they are carbon. And when you get rid of fossil fuels, you get rid of energy, but you get rid also of a source of carbon, which is essential for human societies. So that's what you have to decide and try to give as a scenario to the population is let them accepting a certain degree of reduction of energy and electrifying the system and finding new source of carbon. And in France, for example, today we are consuming 1,600 terawatt-hours of energy, and the scenario indicate something like 1,100, which is actually, in my opinion, a huge drop. I'm not sure we will succeed in doing this, but this is our scenario. And as you can see, furthermore, is that the electricity now will become, will move from 25% electrical share to 50%, which is a huge change. So can we do really 50% of electricity? And 25% today on the world is one of the records. France is one of the most electrified countries. And, and then the gray part here is not anymore oil and gas, is not anymore fossil fuels, but has become something else. And mainly biogas, bioenergy, of biofuels, I mean, all these kind of things. So why defossilizing is electrifying? Sometimes I have people that asking me this. I mean, it's quite clear. I mean, you want to get rid of those coal, gas, oil, which are emitting a lot of CO2 by by alternatives like solar, wind, which are only electrical energies. So you have to do electricity. No choice. So electrification is a key aspect of the transition. Here is to show that indeed we have the answer from this type of curve, is that if you plot here the CO2 emission per kilowatt hour of electricity produced for different countries, and you compare them in terms of, in blue, hydroelectricity, in green, nuclear energy, and in brown, fossil fuels, you clearly see that those countries like Norway, Switzerland, Sweden, and France, which are using either hydroelectricity or nuclear, like in France, for electricity, have the best CO2 emissions, the lowest CO2 emissions. So basically, when you have to decide what to do to defossilize, you just look, and this is, I mean, you know, this diagram here is valid for almost all countries. The most emitting sectors are transport here, housing, industry, agriculture, and energy transformation. So once you know this, you know what you have to do. I mean, you have to electrify the heating, you have to electrify the transportation, you have to electrify the industrial processes, you have to electrify hydrogen production, you have to electrify heat production. That's what you have to do, and obviously with low carbon electricity. And indeed, when you look at the latest investments, I mean, since here 2004, and you look at the investments in the world in terms of, here, billions of dollars, as you can see, the great majority of the investments are in orange about developing renewable energies, and in green, developing electrified transport. That's the case everywhere in the world. The problem is that renewable energy is not simple. It's not a perfect source of energy. It's not the perfect solution. Here you have, and you know that, but I don't want to spend too much time on this. These are intermittent energy. This is a big problem. They have low surface density energy density, massive material requirement, massive needs of mineral resources. So it's quite difficult. I don't go into the details, but we can discuss it. And I must say that in my country, about 7, 8 years ago, everybody was telling about having 100% renewable energy, very easy. That's what we should do. At that time, I was already against this idea because I thought that this was not possible. And by chance, fortunately, in 2021, the International Energy Agency, which before claimed 100% renewable energy, very easy, that's the solution, published this report named Conditions and Prerequisites in Terms of Technical Feasibility for an Electricity System with a High Proportion of Renewable Energy by 2050. So, of course, when you read this title, you say that they will show that it is possible if we have this condition. The problem is that these conditions are just not attainable, basically, because the main conditions are the following. We need to have, where is it? Three main conditions. Have controllable low carbon power capacity. So we cannot be only on intermittent sources. We have to develop energy storage, which are absolutely not available today at the level that is required. And we should develop new electricity network infrastructure. And I want to give you an example which is really clear. It's the case of Germany. So here in this data, you have Germany, the 15th of March, 2022, 5 p.m. There is no wind, and it's almost the night. So you see in gray, you have the installed capacities of wind and solar. And in colored is the amount that is really produced. So almost nothing. So you may have a huge amount of capacities. If there is no wind and no light, you have no energy produced. It's quite clear. And even though they have these huge capacities, in fact, this day, this particular time, Germany can afford electricity by using coal and gas, so fossil fuels. Even though this is one of the countries that the most invested into renewable energy. Actually, there is a small amount of nuclear, but today it's zero, because Germany has stopped everything in terms of nuclear plants. And a second information also for Germany that you have here is that while they have been really great in promoting renewable energy, this is the capacity installed in gigawatt of renewable energy in Germany. So you say, fantastic, it increases, they do a good job. And in fact, this is the capacity installed of fossil plants. It does not change. Of course, they use them less, but still they have the same amount of fossil fuel plants because they need them when there is no light and no wind. And in fact, this is a figure that I've recently published showing that for the peaks of demand in electricity, if we keep this amount of nuclear energy in France, this hydroelectricity, in order to get to the peak, which is above 100 gigawatts, today it's a little bit less, but if we increase the electricity, we will have peaks that will be much higher. Then we are missing about 20 gigawatts. For sure, in 2050, if we keep the same amount of nuclear energy, so maybe we will have less, maybe we will have more, I don't know, but I just kept this scenario with the same amount of nuclear energy, which is quite a lot. But still, we are missing 20 gigawatts. And there is, the only solution is either you have stored energy during the periods where you had a lot of wind and a lot of sun, but today there is absolutely nothing. Or you use gas, for example, and if we don't succeed to develop technology for storing energy, for storing electricity, the energetic transition in France will be building gas plants. And of course, this gas will be either natural gas again or biogas or whatever. But this is a really important thing. So when we ask about which electric mix, in general, I think this is applying to a lot of countries, in particular those who can manage nuclear energy. So we will have to develop renewable energy, for sure. There is no reason why we should not optimize collecting wind energy, solar energy, hydroelectricity. But energy storage is a key point in developing this renewable energy. We will not have a huge share of renewable energy if we don't solve the storage. For France, of course, but for other nuclear countries, nuclear energy is a key point for addressing the energy. Hydroelectric power, certainly gas will be an important component of the electric mix of tomorrow. Obviously, it should be better if it's not natural gas. It will be another gas, so we have no choice. It can be biogas, but still, I think that we will still use natural gas for a long time. Actually, in 2021, I presented a report to the French Academy of Sciences asking for developing nuclear energy at a time when the former government decided to close 14 nuclear plants. By chance, they didn't do it, and this has been stopped, but that's what we said. We should extend the power plants at least 60 years. Why not 80 years as they do in the US? We have to construct, to build new reactors, and we have to develop research on the reactors, on the fourth generation reactors. This is absolutely essential. We have to develop fast neutron reactors. There will be, as you can see, I'm pushing for having a large share of nuclear energy in France, but I'm clear there is no future for nuclear energy without developing these fast neutron reactors, which will solve the problem of resources in uranium and also managing the waste, the nuclear waste. Okay, so yeah, so for France, actually you could see the history of nuclear. During the 80s, a huge increase in nuclear electricity. Then we stop, unfortunately, building, and then we will, here it's a scenario where we have prolonged the reactor until 60 years, and now we are planning to build a new reactor. That's what the President Macron has decided. 6 reactors plus 8, 14 reactors, but still this will not be enough to reach the 60 gigawatt because the old reactor will stop unless they go up to 80 years. But this is a discussion. Yeah, maybe you have realized that when people discuss about the energetic transition, you know, you meet a friend and you say, hello, how are you? What do you think about the energetic transition? Within a few seconds, you talk about electricity only. You talk about wind, solar, nuclear, and people forget that in the world it accounts only for 17% of the energy. In France, it's 25%. But the biggest problem is not electricity. At least in France, it's not, because it's already almost totally defossilized thanks to the nuclear energy and to the hydroelectricity. So the big problem is the non-electrical part of the energy, which is here, this part. And this part in our scenario is almost 500 terawatt hours. It's huge. How can you do 500 terawatt hours of energy in France without petrol, coal, and gas? And in my opinion, this is the most serious problem, not electricity. I'm fed up with the discussion we have with solar, wind, nuclear, and so on. That's the main problem. And in particular, for the chemical industry, as you know, there is something like more than 100,000 chemical products around us. They all come from the fossil fuels. They come from coal, they come from oil, from natural gas. And when we will get rid of that, what will be the source of carbon? And we have no choice. I mean, it will be biomass, and it can be also CO2 itself. It's a source of carbon. We have plenty in the atmosphere, and we are emitting plenty of CO2. So, which carbon for tomorrow? And we have in front of us a lot of very interesting problems to solve. We have to develop liquid biofuels, bioethanol, biodiesels, biokerosene, in particular developing what we call second generation biofuels. So these are coming from lignocellulosic materials, so those plants that we don't eat, because of course there is a competition with food. We will have to develop methods to produce biogas by different methods, methanization, pyrogasification, and so on. We will continue to use wood to a limited extent, and we have to develop synthetic fuels like hydrogen and capture CO2 and transform CO2 in something useful. So these are not, these are clear in the agenda, but it's not developed at the level that is absolutely needed today. Again, as I said, for renewable energy, that they are not the perfect solution. Biomass is not either a perfect solution. Actually, we have to choose between not perfect solutions. That's the problem. Yeah, actually, if there would be a single perfect solution, we would have used it already. But we have to choose between rather complicated solutions. And biomass is not an ideal energy sources because you have impacts on food production, you have environmental impact, you have low surface density, it's not zero carbon, it's expensive. A lot of activities will require biomaterials, mobility, industry, etc. So there is a real problem with developing relevant methods to really evaluate how much biomass in each country we can use. And this is very difficult. And for example, we soon, as I told you, we will publish a report from the Academy of Science on this problem. And it's quite clear that we will not have enough biomass in France to reach these 500 terawatt-hours that is needed. So it's a problem. So again, if we don't succeed, it means that in 2050 we will continue to use oil and gas. I just want to, in the last 5 minutes, I think, tell you first a few things we are doing in my lab. So we at the Collège de France, we work on methods, technologies to use CO2 as a source of carbon, with the hypothesis that some people have succeeded collecting this CO2 somewhere, capturing CO2 to a large extent. And what we develop is a CO2 electro conversion into products. And in particular, this strategy, which is summarized here. So you have a machine here, which is an electrolyzer, in which you introduce CO2, you introduce water, you introduce energy, preferably low carbon energy, and with this energy, you convert CO2 and water into different carbon products. And the advantage of this is that you have less CO2 in the atmosphere, of course. You have a way to store these renewable energies in the form of chemical energy, because these molecules are rich in energy and stable. And they can serve to make a lot of carbon compounds, materials, molecules, plastics, feedstocks, fuel, pharmaceuticals, and so on. And for example, we recently developed systems in which we developed electrolyzers coupled to solar panels, and we developed copper-based catalyst. Here you see this porous dendritic material here, which is very good at converting CO2 into ethylene. Ethylene here. And ethylene is the most produced chemical in the world. It's about 200 millions of tons. Today it's produced from fossil sources. It requires a high energy, and it's a lot of CO2 that is emitted in this process. So we want to replace it with a system in which you use sun as a source of energy, a system that converts CO2 into ethylene, and this was, you see, published in, is an example published in 2019 as an example. So this question of which carbon tomorrow means that we have in front of us, and as a chemist I'm very happy of that, a huge revolution in terms of organic chemistry. So tomorrow, all the products that we need which today come from the petrochemistry, urea, ammonia, ethanol, methane, methanol, diesel, kerosene, olefins, all sorts of carbon compounds will come either from biomass, once you develop all sorts of transformation, fermentation, methanization, gasification, pyrolysis, and so on, that you have to optimize in terms of yields and so on. And also another source will be using the renewable energy and electrolysis of water and CO2, doing CO2 hydrogenation. This is the future of organic chemistry. I go just to, yeah. So I just want to finish on this message, of course, that we know quite clearly where to go, but again, if the end of the world is tomorrow, I mean in 2 or 3 years, I mean, no way, it's the end. But if we have some time, and at the same time, as I said at the beginning, we also try to adapt the world to the high temperatures and extreme events that will occur, we have a lot of very interesting problems to solve. And I used to say to, not only to my students, but to all the young people that I meet, that they have a fantastic opportunity with this project of climate change, energetic transition, a fantastic opportunity to develop their ideas, their mind, their time towards research, basic research, technological research, industrial research. So what we have to do is to succeed by giving all these products with the lowest price as possible, with the best, I mean, the greatest efficiency of the processes. We have to produce green hydrogen. We have to develop technologies for recovering and recycling metals, plastics, batteries. We have to still continue to improve photovoltaic cells in terms of stability, yield, sustainability. We have to go again to clean metal extraction. We have to decarbonize industry, in particular steel. That's what I show here. You know, today steel is one of the product of the industry that produces the highest share of CO2. So today, this is a process. This is one of the few equations that I show you. We need carbon to transform iron oxide into iron, into steel. But if we could use it with hydrogen, do it with hydrogen, and hydrogen not coming from methane but coming from water, then we make a big progress. But this is still not available at a price and at an efficiency that is good for the industry. But we have to work on it. And we have to, as I said, develop biomass valorization. We have also to work on a new nuclear system, the small modular reactors, the fast neutron reactors. We have to work on new electricity networks. We have to work on new electric batteries. In particular, sodium-ion batteries are developed today, very interesting. We have to develop energy storage. I told you about green organic chemistry, capture and utilization of CO2. Yeah, a lot of things to do. very interesting. This is for scientists in particular, chemists, physicists, biologists. So here are a few last questions that we have hold to answer, actually, because there is no unique answer to that. What credible reduction in energy consumption? That's probably the most important point. If we will accept to decrease our energy consumption, and to which level? What is the realistic proportion of electricity? Today, in my country, we claim that we can do 50% electricity. I don't know, it will be very difficult. What electricity generation mix? I have mentioned the position of the Academy of Sciences. Energy storage requirements, we have to do that. And how can we build a consensus on a realistic trajectory? That is a political question, but to me is a very important. And the two last lines are maybe the most important one. We have to believe, at least in part, that research, innovation in industry will provide some solution first. And second, again, I insist, the climate will change. We will not stop climate change in the next years. We'll continue to use fossil fuels, so we will have the temperature increasing. So the new paradigm is that we have to develop policies to adapt to this change besides the energetic transition. And I thank you for your attention.
Thank you. So we open the floor to questions. Maybe I'll have the honor to ask the first one. So you have shown that, using some clean hydrogen formula that you can decrease, hopefully, the making of steel, the carbon emission. But then the other process I haven't seen you talk about is the formation of concrete. When we make concrete, we release a lot of carbon dioxide. What will you do?
So steel is quite clear. You have shown that with chemistry we can do it. Concrete, in fact, is much more difficult because the CO2 emission is not coming because you use, it's partly because you use fossil fuels to get a high temperature, but it's mainly due to the fact that you use calcium carbonate, and then the carbonate is releasing CO2 massively. So the only thing you can do in concrete plants is to capture CO2 and do something useful with CO2. That's the only thing you can do. I've not seen any project in the industry, in the concrete industry, which changes dramatically the process. The way they decarbonize the process is by capturing the CO2, and also since you need heat.
Yes.
The second aspect, but this is true for the whole industry, if you could replace fossil fuels heat by electrical furnaces and these kind of things, and of course with electricity, low carbon electricity, that will also be part of the solution.
Okay, thank you. So,
I am not a scientist, Professor, so I will ask you a question not in this field. But I have two questions. Europe has the most advanced trading of carbon emission. I think it's a market which is around 2 billion euro per day. So my question is, how do you understand the advantage that this market has brought to Europe in terms of forcing the largest polluter to move slowly and improve their production? And my second question is a political question. Last week we had the professor, the dean of the School of Sciences Po in Paris, which was foreign minister of Spain a few years ago. and the subject was Europe in transition, and we asked her, what was the most important issue facing Europe, and where the volunté of a European partner were the strongest. And interestingly, she said it's energy transition. Yes, we have Russia, yes, we have other problems, yes, we have integration, but the energy transition is our most important issue. So that's my two questions.
Yeah. I would agree with you that the energetic transition is the most important problem. In fact, I'm not sure of that. Because we have also a lot of other problems. We have social problems as well. We have, we have war in Europe. So there are many problems, and a country like France, has limited means in terms of investment, because we have a debt that is huge. So we have also financial problems and so on. So we have so many problems, but in terms of now addressing the energetic transition, as Europe does, it's not as simple as you maybe mean, because in fact there is no energy policy in Europe. Each country is allowed to do whatever it wants in terms of energy. Germany could decide suddenly to stop nuclear energy without having a general view of what should be done at the European level. So yeah, I don't know how to answer your question. I think that I want to say that again. My opinion is that the European Commission and the European Parliament is all the time giving objectives, in my view, which are not always realistic. And this makes a lot of pressure on the governments, it makes a lot of pressure on the industry, it makes a lot of pressure on people, and there is a kind of disconnection between, in my opinion, between the European Union, the Parliament and Commission, and the people in the countries. And I think it's going a little bit too far in that direction. And that's why, you have heard the kind of messages that I'm telling, that we have to be more realistic. And yeah, sorry, I'm not very clear about this, but. Yeah.
And Miss Sue, yeah.
Thank you, Professor, for the very insightful lecture, and also appreciate the realistic view that you promoted, to put us back into perspective. My question is pretty simple. Is on your last slide, on the last sentence, you mentioned that adaptability to climate change. So in your view, and you said that some policies are required to address that. So in your view, what would be some of the policies that you would encourage the government or people to have? Yeah.
Maybe you remember, actually, I don't know if we can go into not the last, actually, the first, because here. This is a list of questions that we have to address. In fact, it's very specific to each country. Of course, a country close to the ocean has not the same problem as those which are within a continent. For example, countries with a lot of population along the beach has not the same problem as those who have everybody in big towns. So here is just a series of issues that we could, but it's not done yet. Actually, I'm starting to work on this problem, and I started about 2-3 years ago. And when I talk to people around me, and especially I remember a discussion I had with the director of the School of Economics of Toulouse. And I told him that I was surprised that I could not see any study publication about the cost of adaptation done by an economist. And he told me, yes, that's true. And you know why? It's because, and it happened to me, when you talk about adaptation, it means that you have given up with the 1.5 degree. So you are classified as, I don't know, climato-skeptical or whatever. And I have sometimes this problem when I talk about adaptation, because people complain that if I'm interested in this problem is because I don't care about fossil fuels and so on. Yeah. So, I mean, it's when you ask me which policy, my first answer, it depends on the country. So each country has to see how to adapt towns, agriculture, hospitals, because new disease will appear, certainly when we will have 3 degrees rather than +0, and so on. So, but we have not yet started, again, because we are focused on this 1.5 degree. You know, I dare to say that I see as a significant problem of the Paris Agreement that we have given very precise numbers. 1.5 degree in 2100, 0 carbon in 2050. So people have been blocked on these numbers, and this is not good. Of course, we need to be ambitious, as ambitious as possible, but I think that today, in order to attack the problem of adaptation, means that we accept that we will not have 1.5 degree. Because of course, if we have 1.5, we don't care about this. Yeah.
We have Christine Law there.
Yes, Professor. You know, here in Hong Kong, we've always regarded the French energy situation as quite unique.
Yeah,
So I was just wondering whether you can summarize for us what are the lessons we can take positively and negatively from France?
What makes France unique is the electricity, not the rest. The rest is like other countries. I mean, I didn't show it, but another reason why France has, I mean, besides CO2 emission, has to do the energetic transition, I mean, defossilizing, it's because we import everything, oil, gas, and coal we had, but we stopped everything almost. So we are importing, and this is very expensive for the finances, the French finances. So, but what is unique is the electricity. I think we are the most nuclearized country in the world. And this was not a decision based on climate, because it was more, I mean, it was more on the period when there was this oil crisis, and the government decided, and this is maybe the most important point. The reason why France moved to nuclear energy is because the sovereignty was the most important point for this government. The idea was we should not depend on someone else to get the energy. Of course, it's not possible for 100%, but this was really the important point. So my answer to you is the following. The lesson we can have from that success, because I define it as a success, is that the only parameter to define whether a policy is good or not is not exclusively the amount of CO2 that we are emitting. It's too simple. And actually, the problem is that people function like that. You say, we can do this, how much CO2? We can do that, how much CO2? And this is the only parameter that we are comparing. And this is very bad, because there are many other parameters. And in particular, the energetic independence, the energetic sovereignty is very important. I had some slide that I didn't show. It was about this very important question. If we do the energetic transition, of course, it's for diminishing the CO2 emission, but also we have to have in mind all the time that we don't move from a strong dependence to another dependence. Okay, and if you take this into account, you will have a different policy, not only just reducing fossil fuels. So yeah, France has been driven by this important objective of being independent in terms of the energy.
If I can just follow up, because one of the greatest issues right now in the world is precisely that, energy independence, energy dependence, and energy security.
Yeah, exactly.
So is France actually a good example in terms of, I guess what you have? You showed a graph where we saw, for example, in Norway, right, they're almost all driven by hydropower because that's what they have.
Yeah.
But they're relatively small.
Yeah.
France is much bigger,
Yeah.
Germany is much bigger, China is even giant size. So in terms of the pursuit of energy independence, France has really gone quite a long way, right? And what you're really saying is, don't lose that, right? And then it's also linked to cost. Yeah, I mean, there are many, many, many reasons. That's what you're saying. But maybe some reflections from you, because Germany, for example, right now is scrambling for sources of energy, having to pay a lot more. So I'm just wondering, you must be looking at also the broad macro picture. Perhaps you can share some thoughts with us.
Yeah, it's true that one good point with renewable energies, I mean solar and wind, is indeed because there is wind and sun everywhere on the planet. So each country, if it succeeds in capturing this energy, will contribute to their sovereignty, their independence. So this is a good reason to do that. But the case of Germany shows that it's not that simple. And again, because of this intermittency. So I'm surprised. I'm very surprised. I mean, I was, French people, for a lot of French people, in particular politicians, they always, when they want to explain something, when they explain anything in the past, was always to show, look, Germany. It was the kind of model. In fact, in terms of the energy policy, it's not a model. It's a very bad model for me. I knew that before, but it's not a very good model. And they continue on this way. For example, Germany is one of the countries which believes in hydrogen very much. But all the scenarios that they develop imply importing hydrogen from other countries, which is quite strange, because of course they need so much hydrogen, so they know that they will not be able to do it on their country. So they imagine having hydrogen coming from Morocco or whatever to huge extent. So I mean, you see, it's very complicated. So and I don't understand because in my opinion. The independence, the sovereignty aspect is key. in thinking of what kind of energy policy we should develop. And France should have this in mind too. And I think the present government is taking care of that. I think so. Yeah.
Okay. Oh, one last question over there.
Thank you for this enlightening discussion. I wanted to pose a question regarding nuclear energy, and in particular, I'd like to ask your opinion about the extent to which public perception of the safety of nuclear energy impacts the feasibility of the otherwise realistic goals that you have presented to us. And then similarly, to what extent do the required adaptations to climate change based upon the realistic goals disproportionately impact developing economies, and in particular the global south, given that many of them have very rural populations and rugged terrain?
So as for the first point, you are asking about acceptability, right? Yeah. France is probably a unique country also in terms of having a population that has for a while accepted nuclear energy, I mean, quite immediately. Even though, you know, in the 70s and the 80s, the government didn't ask anything to the population. They did nuclear energy, the plants and so on. But the acceptability of nuclear energy was quite good. In 2012, when François Hollande was elected, by some kind of, I define it like that, awful agreement with the Green Party, he decided to stop 14 nuclear plants, which would have been dramatic. That's my opinion. Now, when Macron decided not to do it, even though he stopped one reactor in Fessenheim, still the announcement of these 14 new reactors was relatively well accepted, of course, except the Anti-Nuclear Association and so on. But I would say that all numbers, I mean, all studies show that a majority of French people accept nuclear energy. So something like 60%. And of course, they are asking to do the correct things with the waste and so on. That's what we do, actually. Nobody in France died due to any contact with waste and so on. So it's one of the human activity that is the most controlled on Earth, I would say. Even though you may have some accidents someday, but yeah. So the acceptability is good. It's not true in all countries. You know, because when we discuss about Europe, I mean, one of the big problems is that every day there is a conflict between Germany and France about the place of nuclear energy in the energy mix of Europe, every day. And Germany trying all the time to destroy our nuclear economy, and France trying to keep it. Yeah, so, but in Germany, the population is very much against it. So we have to accept it, and of course the government have to take this into account. And I'm complaining about the energy policy of Germany, but I understand that if the population do not want nuclear energy, the government has to take this into account. But this is not the case of France. And the second question, I don't remember.
Yes. Will developing countries, particularly in the global south, be disproportionately impacted by the need to adapt to climate change based upon their rurality and the ruggedness of terrain?
Yeah, but you know, climate change, energetic transition, adaptation will of course, will demand a lot to the industry, but will demand a lot to to the population. So anyone will have to change his habits, its thoughts, its So I don't know how to answer your question. Yeah.
Right. I think that we take that as a
Yeah.
cue, to end a very thoughtful and intellectual discussion. Thank you, Professor Marc Fontecave. I think that we should just sit down and then let the photographer take the picture of the room. Okay.
Thank you.
Professor Cheng, the souvenir.
Oh, souvenir, yes.
Yes.
Yeah, right.
Thank you, Professor Fontecave, very much for such an insightful lecture. And Professor Cheng would like to present you with a souvenir on behalf of CTU. Professor Cheng, please. Excellent.
Thank you.
Yes, please sit down.
Yeah, thank you.
Dear guest, may I invite you to remain seated because the photographer is going to take a group photo for all of us.
So, can little bit close, little bit. Okay, close. Okay, yeah. Okay, ready? Okay, very good. Okay, shall we? Okay, 1, 2, again. Thank you.
Thank you very much.
Thank you, everybody, for coming. And that is the end of our lecture. Thank you so much.